right? Keep chugging right along. We're in section 4 now. Have we messed with the ozone? So moving on to the new subject of the ozone layer. So if you remember, there's the troposphere, which is down at the bottom, and then there's the stratosphere, which is above it. And so within the stratosphere, there is a layer of ozone, O3. And that stuff basically absorbs all the UV radiation that's coming in from the sun, 95% of it. And that's good because UV radiation actually damages skin, causes sunburns and cancer. And so it's a protective layer that helps us out quite a bit here on the planet. So less ozone in the stratosphere then allows, of course, more harmful UV to get to the Earth and creates all kinds of problems here on the Earth's surface. So ozone up there is good. Ozone down in the troposphere, on the other hand, is actually not good at all. It creates its own level of problems. And so we were using some chemicals, and that created some problems. But in the early 1980s, scientists noticed that there's this huge seasonal depletion in the ozone layer in the stratosphere. And they referred to this as ozone thinning, and it happened mostly over the poles, the Arctic and the Antarctic. And where those major depletions occurred, just because the atmosphere is thinner there and all of those kind of things, we called those ozone holes. And so that's what this picture down here is. We had 2 holes in the ozone layer. And so if you look at this next page, you'll see that the ozone layer actually shrinks and grows through the seasons based on the amount of sunlight and all of those kind of things. So during October and November, 40 to 50% of the ozone in the atmosphere over the Antarctic and the Arctic is depleted. And that's because of the change in sunlight and all of those kind of things. And so scientists noticed this back in the day, and they kind of researched it a little bit, and they actually found what was causing this depletion to occur, and they discovered or deemed the culprit responsible for it was CFCs, chlorofluorocarbons. These were chemicals that we were using in like air conditioners and refrigerators and like spray cans, like hairspray cans and things like that, aerosol cans. And so they basically said these CFCs are naughty stuff. And they found some other ozone depleting chemicals too, but CFCs were very harmful because CFCs are extremely chemically stable. They don't break down in nature on their own. They last a really long time. And so this is a problem. So in the troposphere, they act as a greenhouse gas and warm things up. They eventually work their way up into the stratosphere, where then they break down ozone molecules and create ozone depletion. And so CFCs weren't very good. And because they're so stable, they can last 65 to 385 years floating around breaking stuff down. And so these CFCs were not exactly good stuff. And the way they work basically is they work their way up into the atmosphere. The sun kind of gets involved with them, kind of breaks down the CFC molecule just a little bit and releases a chlorine atom. That chlorine atom then goes out and grabs a hold of an ozone and breaks it apart, creating O2 and O. The chlorine then kicks that O off. It's now a free chlorine again, and then the process repeats itself. So it just keeps breaking more ozone apart over and over and over again for up to 385 years for one molecule. So you can see how this could create a real problem. And so how do we solve this problem? Well, we have to get the CFCs out of there. And so why? Well, that creates all kinds of nasty effects. From a human perspective, you're going to get more cataracts, you're going to get more skin cancer, you're going to get more sunburns, and you're going to get your immune system suppressed from all of this extra UV light. So that's bad. From a food point of view, you produce less crops, you reduce the amount of plankton in the ocean, you reduce the productivity of forests, so that's a problem. Wildlife, more animals get cataracts just like we would. You get less aquatic species because they're more sensitive to UV. You reduce the populations of phytoplankton on the surface of the oceans, and you mess with the food web in the oceans. From an air pollution perspective, you get more acid rain, you get more photochemical smog, and you get degradation to plants and plastics and all of those things that are exposed to UV light. And then also global warming can occur because CFCs are a greenhouse gas. So all of these things are natural capital problems as a result of ozone. And so way back in 1987, the Montreal Protocol was created. And this was a treaty that was put together in Montreal, of course, to control the production and consumption of these CFCs, these chemicals that are messing with the ozone layer. And then that was reinforced and strengthened in 92 at the Copenhagen Protocol. And so 191 countries ratified and agreed to do this, that they're not going to produce or use CFCs anymore. So they have to find substitutes for those. And so they've been doing that. And so some developing countries are still using CFCs. The United States isn't. We joined the bandwagon, and we got off of the old CFCs. And so we use them, but they're now regulated. Before, you could just take and poke a hole in your refrigerator and let the refrigerant go. And now that is against the law, and it has to be handled by certain people that know what they're doing and are trained for those kind of things. So, a little humor for you to end things with. Good times. All right. That's it, guys. Peace, love. Bye-bye.